Okay, so first one, we have 1 over 5 x cubed. So the number 1 over 5 specifies the x on the bottom, so it becomes a negative power, so x to the minus 3. Second one, 4 root x to the 5. Well, the 4 is outside the root, so it stays 4. And root means power half. 5 times a half is 5 over 2. Yeah, remember power's in the top, root's on the bottom. Third one, x over root x. So that's x to the 1 over x to the half. We take away powers because we're dividing. So x to the half is 1, take the half to the half. Okay, second one. We have y is x, add cos 2x. And we have that x is between 0 and pi. Well, it might be a good idea to sketch this in your calculator. Make sure you're in radians. Yeah, so delete that. X plus cos 2x. Use the b window if you need to. So we're between, actually I'm going to put limits on here if you can remember how to do it. So you put a comma, square bracket, 0, comma, pi, close the bracket. So there we go, so you can see that. So you can clearly see there's a maximum and a minimum point. So to find stationary points, we differentiate. So dy by dx. Well, x differentiates to 1. Cos differentiates to minus sine. For this 2x, I need to differentiate that as well, so that gives me 2. So 2 just goes to the front. And it's stationary if the derivative equals 0. So there's no gradient. So to solve that, so I'm going to get sine 2x. I'm going to take the minus 2 sine x to the side and then divide by 2, so it equals a half. I'm going to change that to y. So I've changed the range. Then I just solve sine y equals a half. So do arc sine of a half, and that gives you pi over 6. And then do 180 take away, so pi take away pi over 6 is 5 pi over 6. And that's what y is. Well, to be fair, I shouldn't have used this y because I put y there, so I'm just going to change it to capital Y. That's what capital Y is. So pi over 6 and 5 pi over 6. So to get x, I'm going to divide that by 2. So pi over 12, 5 pi over 12. Now I need the coordinates, so I'm going to sub them back into there. So I would get pi over 12 and sub pi over 12 into there. So let's just do the cos bit, cos 2 times pi over 12. So I get pi over 12 plus 3 over 2. And then do the same with 5 pi over 12. So I get 5 pi over 12 plus, that's into there. Sorry, minus now, minus 3 over 2, which I don't think you can see. There you go, you can just about see that. Okay, third one. So partial fractions, so x plus 5 over x plus 1, x minus 3 cubed. So remember, I can write that as a over x plus 1 plus b over x minus 3. Now I need an x minus 3 squared as well. Remember, I need both these terms. So I'm going to times it all by the bottom here. So I get x plus 5 is the x plus 1 cancels out. So I get x minus 3 squared. Here, one of the x minus 3's cancels out. So I get x plus 1, x minus 3. And for this one, the x minus 3 squares cancel out. So I get an x plus 1. So I pick my magic numbers. So I'm going to start with x equals 3. So on the left hand side, I get 8. That turns to 0, that turns to 0, that turns to 4, so 4c, so therefore c is 2. I want to sub in x is -1, so I get -1 out of 5 is 4, -1 take away 3, -1 take away 3 is 4, -4 squared is 16, 16a. That disappears, so therefore equals 4 divided by 16, so a quarter. And just pick a random number, so I'm going to pick 0. So 5 equals -3 squared, so 9a, -3b plus c. Well, that's 9 over 4, because a is a quarter. Take away 3b plus 2. So 3b equals 9 over 4 plus 2, take away 5. So 9 divided by 4 plus 2, take away 5. So 3b is -3 over 4, so therefore b equals -1 over 4. So I sub the numbers back in. So I can write it as, what was it, a quarter, or I can write 1 at the top and times the bottom by 4. B was -1/4, so -1 over 4 times bottom, and C was 2. Okay, fourth one. ln 2x plus 1, take away ln x equals 5. Now, remember, I can't just factorize out ln. That's the worst thing you can do with ln, remember. So instead, the rule is if I take away an ln, I can divide what's inside ln, so 2x plus 1 over x. Now, this side, I can leave as 5, or if you want, you can change to ln e to the 5. To get rid of an ln, if I use this, I'll just cancel out the ln's. If I just keep this at 5, I'll do an e on both sides. So the e and ln cancel out, so I get 2x plus 1 over x equals e to the 5, times it by x. 2x plus 1 is x e to the 5. Get the x's on one side, factorize out the x, and then divide by it. So x equals 1 over e to the 5 minus 2. And the last one, I'll give you the velocity is 5et plus 2, and I want the displacement in the first 3 seconds. Well, dv, I've got velocity, and I want to go up to displacement, so that means I integrate. So I'm going to integrate 5et plus 2, and I'm going to integrate between, well, the first 3 seconds, so I start with 0 seconds, and I end with 3 seconds. So what differentiates, giving me et? Well, just et, so therefore 5et differentiates to me 5et, so 5et integrates to give me 5et, 2 integrates to give me 2t, and since I've got limits, I don't need a c, so 0 and 3, sub the top one in first, so 5e3 plus 2 times 3 is 6, take away sub 0 in, so 5e0, sub 0 inside, I just get 0, so I get 5e3 plus 6, 5e0, well, e0 is just 1, so 5e0 is just 5, so to get 5e3 plus 1 meters per second. Then if you want, sorry, it's just meters, it's displacement. Then if you want, technically I can get 101 meters to 3 significant meters.